My mic is on. Okay, so looks like we're going to get ready to get started. So greetings, everybody. My name is Sam Deiter. I got to stand a little bit away from the speaker over here. My name is Sam Deiter, and this is Building Open Worlds in Unreal Engine 5. So, in today's talk, we're going to be covering the following outlines. We're going to talk about Open World Overview. This is going to go over just the tools, their names, right in the beginning so that we know kind of what we're talking about through the rest of the presentation. Then we're going to talk a little bit about the Open World template. This is a template map that is provided for you inside of Unreal Engine 5 that allows you to automatically get started working, building a massive open world. You don't really need to set anything up, so we'll go over that. Then we're going to talk about each of the open world tools individually. This is going to be like HLODs, data layers, the world partition editor. Those are all the ones I can think of off the top of my head. And then finally, we will follow up with some open world debug commands to finish everything out. So let's go ahead and jump in now to our open world overview. And the first thing that we're going to be talking about is the big picture of all the tools. So the first tool, or I should say the first portion of this that I want to talk about is when you're crafting massive open worlds, you're going to need to use all of these tools. Now, there are two tools that are missing from this particular list because they're a little bit outside the scope of this. This is mass entities and smart objects. Those are for handling AI. All the stuff here, though, is for building your worlds. So first on the list, we have world partition. Now, world partition is an automatic data management and distance-based level streaming system that allows you to grid up your world and then stream those particular grid sections and the content within them based off where the user is in the world. We'll cover that in a lot more detail in just a little bit. We then have our one file per actor. What this is for is to help reduce the overlap between people who are working on the same project. As many of you know, when you're working on an Unreal project, you have the UMap file, which is your level file. And this can be kind of a production bottleneck, right? When you have multiple artists working on a massive world, only one artist can have that UMap file checked out at one time, and this presents a bottleneck. This one file per actor helps to alleviate these by allowing basically every single actor in your project to become a file. So if you have that directional light there, that directional light is now a file that you can check in and out of Perforce. So you can check it in and out of source control. And that is for everything that's going to be placed inside of your level. Again, what this really does is it allows people to not have to work over the top of one another or constantly pinging somebody to check something in or to update something so that you can go ahead and free yourself up so that you can start working. We then have, and my notes list is a little messed up, but we're going to talk about HLOD. HLOD is a hierarchical level of detail. And what this does is this allows you to basically process your entire world, bake either a new version of geometry that's off in the distance with either, like I said, new geometry, new textures, or you can merge them all together into an instant static mesh and does this for you all programmatically. So what this does is it helps those really, really, really far things off in the distance still look like they should, but you don't have the massive memory overhead that it would require to draw all of those objects. It's going to do it for you all programmatically. Excuse me. All right. Let's now talk about virtual shadows. So, one second here. It looks like my notes are messed up here. So basically, virtual shadows, what they allow you to do inside of your scene is they allow you to get really, really awesome far distance shadows, or you get really, really fantastic shadows up very, very close to objects. If you kind of look at shadowing in Unreal Engine 4, you notice that when you have an object have a shadow cast onto it, when you look at that object very closely, you'll notice there'll be some shadow acne, or the shadows just won't be as precise as you want them. And no amount of shadow sharpening or shadow bias filtering will kind of bring those shadows back to their nice, crisp state. Virtual shadow maps help, virtual shadows, not shadow maps, virtual shadows help alleviate these problems by giving you very, very nice, shadows very close up, but also giving you shadows very, very far away in the distance. And again, we'll talk a little bit more about each one of these tools in detail in just a little while. All right, let me just pop back up here to level instancing. So level instancing is still similar to how our old level workflow used to be. However, you don't necessarily have to use levels in the strict sense of this one area is level 1 or this one area is level 2. You can use levels to actually spawn other levels inside of them. So for example, you could have a level that contains the foundation of a building, spawn that in multiple locations, which is actually something that is new to Unreal Engine 5. You didn't used to be able to spawn multiple levels inside of a level. So you can actually, with level instancing, set up your project so that each one of your buildings or vehicles or whatever you're happening to build in the world, you can have a level that acts as a foundation that you can then put other levels on top of and start to kit bash these things together to build these massive open worlds that don't necessarily have to be built out of one single level instance. And this is really, really powerful because this means that you can go in and you can modify content in one area and then have it amplify all across your entire content pipeline. So I can make a change in one location and with level instancing have that go all the way through my entire pipeline without me having to go through and actually change all of that data throughout the entire project. So the next thing I want to talk about is data layers. Now, data layers are a system within World Partition that is used for organizing data, but the cool thing about data layers is you can use them both inside of the editor as a way to manage data, but you can also use them inside of your running project to turn things on and off. A really good example of this is in the Matrix Awakens demo. All of the tops of the buildings are done as data layers so that they can then be turned off when the game is run on Xbox and PS4, because that was a little bit of extra data that they couldn't really keep to maintain, but we want to make sure that we have an experience that is the same across multiple platforms. And again, data layers, what they allow us to do is they allow us to tag different data, put it on that layer, and we can then use them either as an organizational layer inside of the editor or as a way to help reduce complexity at runtime. All right, so next we have virtual textures. Now, virtual textures in the sense of the open world tools are only required when you want to build your mini map. So the open world tools are going to provide you with a mini map, and in order to get that to draw, you will need to enable virtual texturing. Virtual texturing, I don't want to get too far into the weeds on it because it's a very big topic into itself, but one of the big benefits of virtual texturing with the massive open worlds is that when you go to draw an object, even if you can see one single pixel of that particular piece with the old style of rendering, you'd have to render all of the content that's associated with it. So let's say that we're building a big mountain range, right? And all we can see is one pixel of that mountain range. The rest of it happens to be occluded by something else. In our old system, without using virtual textures, we'd have to draw that entire object. Introducing virtual textures, it allows us to quad things up. Now we only have to draw that one little pixel. Now, this is a great oversimplification of it, but that's one of the advantages of it is it allows us to have more content, but only draw the content that we actually need to see at any one given time. And the last object, or last entry on this list is Nanite. And although you don't need to use Nanite to build these massive open worlds, Nanite does help because it works with both virtual textures and virtual shadow maps. And it's really going to help drive the quality home, right? Using Nanite is really what's going to help get these really, really fantastic looking scenes that have a lot of depth and a lot of realism. And if we look, just come over here, there we go. And this is what we get when we bring all of these tools together. So right up here at the top, we have the kind of the big downtown city from the Matrix Awakens demo. You can also see down here on the right over here, this is just taken right from one of the streets. And then over here we have the, I just forgot the name of this one, Ancient demo, Valley of the Ancients demo Always forget that one. And this is showing us basically the open world tools plus a little gameplay. And the Matrix Awakens one is showing us more of a city-style scape with some gameplay. So we have a combination of both, and you can see, if I have an open world that's going to be more, say, mythical or fantasy, you can take a look at the Valley of the Ancients demo and kind of see how we kit-bashed a bunch of stuff together to make that one. And if you're targeting more realism or something that's more hyper-realistic, more modern, you can check out the city demo to get a sense about how both of those were built. And again, both of them utilize the exact same set of tools, which is really, really amazing because these two demos couldn't be any different from one another, but they still both run at 60 FPS. And they both allowed the creators to do pretty much whatever they wanted with these tools. So with that out of the way, let's go ahead and talk about the open world template. So I am going to pop over here to Unreal real quick, just make sure my Unreal is going. And there we go. All right. Let me come back here. Hold on one second. Got to do a little window magic. So right out of the box, the blank first person, third person, top down, and vehicle game are going to have support for massive open worlds right out of the gates. What I mean by that is if I come up here to File, I'm going to go new level. Actually, sorry, take that back. I'm going to do one other thing first here. We're going to open up my launcher really quick. I'm just going to bring this on the screen for you. Let's hope my launcher actually works. Shazam! There we go. All right. Come over here to the engine, and we're just going to launch this really quick because I want to show you something in the actual project browser, which I can't get to from my current window. So just give me a second for that to come up. And there we go. And of course, it doesn't have any of the templates that I need here. So go figure. So let's just pretend that this window right here looks just like this window I have right here, because they are the same if they had the content in there. And the ones that I have highlighted, the blank, the first person, third person, top down, and vehicle, those are all going to have the open world template ready to go. That doesn't necessarily mean you have to use it. It just means, and I know that this particular slide will work, so if I come back over here to my engine, if I come up here to my File, New Level, I have this open world, empty, basic, and then empty level. So any of those templates that I was using before, when I go to make a new level in it, I can just click something like this, open world, hit create, and there we go. I have an actual level that is ready to work with the open world tools and all of the things that actually need to be set. And that's what I'm going to be going over in the next couple of slides. You can set all this stuff up for yourself, but working from the template ensures that you have everything set up ready to go, including this first option of enable streaming. So under world settings, under world partition, you can check on enable streaming. This is only supported, though, if you are using the world partition template. So what we're going to do, we're going to come over here, and of course it's not up, so we're going to go to Windows, World Settings, and there we go, World Partition, Enable Streaming right there. So again, this is enabled by default because I'm working inside of the template, and I'm just going to go through and show you kind of the different options that they have. You can set them up for yourselves, but again, work from the template because the template's already going to do all of this for you. All right, so we talked about the open world and the empty open world. The main difference between the two, one is completely empty, and the open world, this one right here, this comes with world partition enabled, one file per actor enabled, data layers, hierarchical level of details. This terrain is about 2 by 2 kilometers. Has a special material on it for landscape. The lighting's been set up for outdoor. It's got a sky atmosphere, skylight, directional light, exponential height fog, and volumetric clouds. So basically, this template has everything that you need in order to just get started working, populating a level, or building it out the way that you want. You don't have to work with these tools in any different way. You can still work with the landscape by, say, importing a custom height map and just placing down actors. It just means that all of the extra little options that you would need to enable have already been enabled in setup for you. And setup is a key word here because the grid, which is the main way that things are streamed in and out, can be a little difficult to understand when you first open it up. And the reason I say that is because this cell size right here, this is 25600, so this is 256 meters, right? Because Unreal uses centimeters. So this can be sometimes a little confusing. And basically what this grid is doing is it is saying that our cells are going to be around 256 meters square. So each one of these cells are these little white lines that you see right here, and we can actually see these in the editor too. If I come over here back to my editor, and we're going to go preview grids, there we go. There are my cells. So all the information that I place inside this world is going to be located inside of one of these cells. And the cells actually have a distance at which they will be loaded and unloaded. So by default, you have a cell size of 256 meters. And then at 768 meters, that information is going to start to disappear or start being cold. And all of this is taken care of for you, again, automatically by something called the streaming source. So let me just pop over here real quick. So the streaming source is basically a grid of cells within a, sorry, said that wrong. The streaming source at runtime helps stream in and stream out a series of cells, or those little, pop back over the editor. Basically, these little white boxes that you're seeing, it's going to start to stream that content in and out. Now, streaming is determined by two things. It is determined by either your player controller, or there is an additional streaming source. And you can see, if you add it right here, there's the world partition streaming source. What this does is, let's say that you teleport your player from somewhere in your world to somewhere else in the world, and that teleportation happens very fast. So as soon as you get that person there, you want the content to be shown. You don't want the person to get there and then all of a sudden the content starts to kind of populate. That is what this streaming source component does. So you have one that's actually on the player controller. So I'm just going to come here, and we're going to go to my, let me do one other thing here, 1 second, sorry. So we're just going to add a feature. Oh, of course, there's no feature content packs on here. I can't do that. Oh, that's why. So right here, in my third person, give this a second to start up. And I need my here's my player controller. So what we're going to do, so this is our world partition streaming source. We can add this to our player controller. Again, by default, this should be added to our player controller for using, say, the blueprint, the third-person blueprint template. It will already have that set up. So we won't need to actually add this to our player controller. I'm just showing you this now in case you need to know where to use it. And one other thing, I'm going to come over here to my class defaults, and there should be, here we go. So there's also our world partition enable here. So there's two ways that I can enable this. I can either add this as a component right here, or it is built into our player controller. We can see this right here, world partition enable streaming source. Streaming source should activate, and the runtime grid should probably be called, you can see what it's called right here. Ready to go. Oh, there we go. Main grid. So we'll just copy this over here real quick, and we'll tell it's the main grid. G buttons keep messing me up. We'll just type it in. There we go. I'm also going to delete this guy really quick. Oh, did I? OK, thank you. Let's try that one more time now. Yeah. Oh, I see what you're saying. Thank you. There's a G button on the side right next to the control. I keep hitting that, and it keeps screwing stuff up. M-A. There we go. And it's got a backslash in there. Of course it does. I swear I can type. OK. So we've talked a little bit about the streaming sources. And again, if you use the template and you're like, oh, this is so complicated, I'm not going to understand any of this when I get out of here after he's done talking, it's all good. Just use the template. The template already has all of this set up for you. And there's a reason I keep pushing on the template. It's literally because one missed checkbox, one missed option, there will be a whole cascading effect of problems and bugs that you'll have to dig through. Just use the template. It's already set up. There's nothing wrong with using the template. In fact, one of the games that you might have played, anybody ever played Ark Survival in here? I don't know if you know this or not, but Ark Survival was actually made off of the first-person template inside of Unreal Engine 4. In fact, for a number of years, it said first-person template when you would run the game in unwindowed mode. So there is no shame in using the template to get yourself started, OK? Everybody does it. Ark is a massively successful game. We actually put in an option so that you could rename your project so it didn't say first-person shooter there. It could now say Ark Survival or whatever your game happens to be. But again, use the template. You can build everything off the template. It is not cheating. It is not cheating to use the template. So, all right. So we're going to talk now about streaming the grid. So streaming and the grid are two vinyl components for the loading of cells around them. When you are actually going through your world, you're going to see in one slide here, towards the end, I'll show you this debug command that's actually going to show you what is being loaded, what is pending loading, what is pending being killed, and what is, I think if there was a failure, oh, I forgot one. Yeah, failed to load. And basically, as we traverse through the world, let me just show you something here real quick. Of course, I can't select from there. One moment here while I get this, because I can't select it out of my notes for some reason. There we go, Control-C. So there's a little command, and we'll go over the command in a few more slides, but I just want to show this to you now. Close that. Really high in the world, so open up my console, hit Control-V, and it's basically the same image that you see up there in my slide, but I just wanted to show it to you because as I traverse very slowly through the world here, we're going to see different things kind of load and unload. This world isn't very populated, so when we get to my other demo level, we will see that, and it will make a little bit more source. Shouldn't try to talk and read at the same time. It'll make a little bit more sense. There is one other cool thing that we can do here. I'm just going to hit play again, and I'm going to hit the tilde key. I'm going to hit the up key. I'm going to hit space and then 0 to disable that one. I'm going to hit the tilde again, and then I'm going to enable the runtime 3D. And this one's kind of cool because it actually shows you the various cells in 3D. It's not any different than the 2D version. This just happens to show you the information, say, vertically. If you have a lot of verticality in your level, that might be something that you might need. So let's go here. We're going to hit escape. And let's see. OK. And let's pop back over to our presentation here. All right. So let's say that you are working on a UE4 level. You are going into UE5 because you want to make use of all of this awesomeness, but you don't really want to manually, say, recreate all of your work. There is a whole page of documentation on how to use Unreal's commandlet system. And for those of you who are not aware, Unreal has an entire commandlet system that can be used to process data at the command line, so you don't actually have to open up the editor. You can run a commandlet to do things like resave all your textures or recompress all your animations. There's thousands of them that you can run. And one of them is this world partition conversion commandlet. The doc link right down there at the bottom goes to the page where I pulled this from, but basically what this will do is it will take your current Unreal Engine 4 level and then run through the conversion process to bring it into a level that can work with all of the open world tools, right? Because you need to have that one file per actor, you need to have the streaming grid, you need to have, there's like 6 other tools. I just forgot the name of like 3/4 of them. Let's see, world partition, streaming source, HLOD, data layers, basically everything that you would need to ensure that you have a good starting point. These commandlets can kind of help you get there. All right, so now we're going to talk a little bit more in depth about the tools. I'm going to open each one of them up so that we can kind of have a look at them. And the first one is going to be world partition. Now this is split up into 2 things. We have our world partition editor, and then you can see here this is, again, an image of the streaming grid, right? Because the individual cells that we see in here are what is actually going to be streamed in and out in this image over here. So the data that we're seeing here, like this green cell here and this green cell here, are going to correlate to what we're seeing here in our world partition. And what I mean by that is, let's pop over here to our editor. We're going to come here to our world partition. Before I do that, I'm going to come up here. I'm going to enable my level filter so I can open up this little map that I put together. So it's just a little thing like this. And so here's my world partition. I'm just going to go like so. And within this tool, I can do a lot of cool stuff. Like I can come here and I can load these selected cells. Maybe I selected too many of them. Hold on. All right, let's try to unload selected cells. There we go. So I unloaded them. If I come back over here, I'm going to hit 2 on the keyboard to go to a little area that I bookmarked. I can come here, and maybe I want to, I don't know, move my camera here, and then let's like unload the cell, and maybe we load all the cells at this location. My camera was under the ground. That's why it looked like it had a little bit of an issue there. Let me see. So the world partition system, this little system that you're seeing right here, this the grid and everything, or I should say the image that you're seeing, this is generated if I come up here to my build and I go to my build minimap. Oops, I did not want to do that. I just wanted to show you that option. There we go, build minimap. What that's going to do is it's actually going to build this minimap for you. And this is actually really cool. This is just a byproduct of using the open world template. Without that, we would have to generate that minimap somehow, which could be actually pretty hard to do. And just by utilizing our open world template, we already have our minimap ready to go. So the next thing that I'm going to talk about is level instancing, but this isn't the typical style of level instancing that you might be thinking of, literally like having a level and then making an instance of all of those objects. The level instancing that we're talking about in this case deals with 2 things. One, how do we kit bash a bunch of assets together without polluting our world outliner or just making it absolutely ridiculously hard to go through our world outliner? And what I mean by that is over here, I'm just going to dock our world partition back. I said dock. There you go. And look at all these rocks that I have over here. Like there's tons of them, right? And this is just, I have a folder. Yes, I know it's a folder of meshes, but there is a ton of stuff inside of here. And it just keeps going and going and going. You can see I unloaded ones and things like that. So how could I cut down on a lot of this and make it so that it's just a little bit easier to manage some of this stuff? And I can do that through either a level instance or a packed level actor. Now, there's a huge difference between the 2 of them. The create level instance, this is going to be used whenever you need to package up something that changes within your project. So inside of Fortnite, all of the bases for all of our buildings are level instances. And we can spawn these level instances inside of other level instances. There's a lot of nesting that you can do now, which previously wasn't possible. You could use them for things like, you can also have, oops, sorry about that, multiple instances of the same level instance in the world. And again, this wasn't possible with Unreal Engine 4. You could only have 1 level instance inside of your world. So and again, the use cases for creating a level instance would be like a point of interest, maybe a house or some type of like gameplay asset setup. So you have some collection of assets and maybe a collection of blueprint code that powers those assets. Packed level actors, or I'm sorry, level instances are mainly for things that need to be dynamic or update throughout the lifetime of your project or your project while it's playing. The packed level actors are slightly different. What they do is they take whatever objects you have and replace them with an instanced static mesh version of that object, and they are purely built to make things run faster. And the Matrix Awakens demo, they used packed level actors for all of the buildings and all the buildings' facades, while in the Ancient demo, they used level instances because some of that stuff actually needed to update with gameplay. So again, the main difference between the two, level instances are for when we want to actually have a little bit of content that changes with the game. Maybe it's a building that explodes. Maybe it's something that updates when the user reaches a certain goal inside of the level. And then the packed level actors are for when we want to take something and speed it up. So let's just pop over here to my editor real quick. I'm going to hit 1 on the keyboard. I'm going to have to reload a bunch of stuff, so just give me a second here. All right. So let's see. I have a bunch of these rocks right here, right? And there's a whole bunch of them. They're like, if I hit Shift E, I have like, I don't even know, 37 of them, right? 37 of these objects. So they are right there. Now, if I know that all 37 of these are never going to move, right? They're just going to be purely used as stuff on the ground. What I could do is I can come here, right-click, level, create packed level actor. We're going to center it at the center bin Z and just press OK. And we'll say new map. And now what should happen, there we go, save my blueprint. And you can see it converted it right here. And if we look inside of my folder, this is it right here. You can see it's basically a blueprint, but each one of these is an instance static mesh component. And the other cool thing I can do about this is if I right-click on this, I can go edit. Notice that my world has kind of gone gray, but I can still see these assets in here. So what I can do is I can come here and I can like make a copy. Maybe move this one out. I can maybe rotate it, move this over here. And then once I'm done, we can go commit. And what that's going to do is it's going to update this, but it's going to update it for however many instances I have placed around the world. So if I was to come back here, and let's see, we'll add another one of these guys over here. Then I'm going to hold Alt and put another one over here, and like so. It's Nanite awesome. Look at all these. There's like millions of triangles right here. So look at that. I did all of that, and then if I just come up to one of these guys, and I go level, edit, maybe I like bring one up for whatever reason, and we're going to go level, and we're going to go commit. And now you see I have that one that's like basically raised up all over the place. And again, this is super powerful because we're going to go to my what the hell did I do with it? Oh, let's do this. There we go. I was looking for my outliner. But now you see I have these new BPs right here. And hold down Shift. So, and there's like, what, 12 instead of having Shift E, 46, right? And out of those 12, it's actually just one, right? But it's one that I have duplicated across the entire map. So that's one of the really, really cool things about these packed level actors is that I can instantly go in, I can come here, I can edit whatever I want, change it, commit. And the other cool thing too is I can also, I can break this, so I could break it apart if I wanted to. So let's say that I placed it down and I wanted to use that as a template to get started on something else. I could then break this, start adding a bunch of stuff, and then make a new one based off of the stuff that I broke apart from it before. So I can constantly be breaking and adding or adjusting. I'm not really stuck using this in one particular way or for one particular set of assets. All right, so one file per actor is something I want to spend a little time talking about because it works a lot differently than you're going to be used to. It also generates a ton of files because remember, one file per actor literally means every actor in my project is now going to have a file. I put a point light in, it's a file. I put a static mesh in, it's a file. I put a skeletal mesh in, it's a file. New blueprint, it's a file, right? They're going to be a one-to-one file that I see on my hard drive versus what I see inside of the editor. This will make your Perforce, this is a little bit of a different flow. You're going to be doing a lot of checking in and checking out through the editor. So the other reason that I want to bring this up is that one file per actor, if you notice here, to enable it, we go to experimental, tools, and then enable one file per actor. The reason that it's under experimental is this will only work when you're using the open world, the world partition tools, and all of the other stuff that comes with the template. This is why I push so hard on the template, because some of this stuff will not work outside of the world partition tools and things like that. So you have to use kind of all of these together to get the benefits of everything. You can't just, at this point, pick and choose which tools I want to use and which tools I don't want to use. We have to use them all. One file per actor can also be extremely granular or done across the entire project. I can have only certain assets that I want go down to one file per actor. You can see here we have, in our world settings, we can use external actors, and this will do it across the entire world. Or if we come down here to our details under packaging mode, we can have external or I believe it's none. I have to look now because I forgot what the name of it was. We go, my details. What did they get rid? Hold on, what version of Unreal is this? Okay. I wasn't expecting that, but so I was expecting this to be 5.0, so they've made a change recently. But basically, in the newer versions of Unreal, 5.1, so the next version that is coming out, you no longer have to worry about packing your one file per actor in the level. It is just going to be enabled or disabled on the entire project. Sorry about that. I didn't know what version of Unreal I was going to be with here at this show. So the next one that I want to talk about is data layers. And data layers is actually one of my favorite things to work with because data layers opens up the layer workflow like you would expect layers to work inside of UE5. So inside of data layers, I'm going to come over here to my editor again. And we are going to my stuff is kind of messed up. That's not the one that I wanted, though. Oh, yeah, there we go. So I don't have any here, but I'm just going to create one. And there we go. So I've created it. And then what I can do is let's just, I don't know, we'll grab some assets. So we'll say Shift-E, right-click, and we can do move selected. Oh, wait, hold on. Move daters to. Let's just create and add selected layers to new data layer. There we go. Let's just rename this one rocks. So I have my rocks data layer, and then I can save selected. I can easily turn them on and turn them off like so. So it's pretty simple, but this actually used to be a little bit complicated inside of Unreal. The other cool thing about these data layers, though, is that I can actually turn these on and off at runtime. And this is really powerful because this means that you have a lot more control over what your project's going to look like on, say, the PS3 versus the PS4 versus the PS5, or say Xbox One X versus Xbox One, or maybe the Switch versus what it's going to look like on PC. And again, the cool thing about these data layers is that I don't have to use them for just one specific thing. I can use them purely for managing stuff inside of the editor, or I can use them for managing performance when this project is run across multiple platforms. So the next tool that I want to talk about is HLOD. Now, HLOD is going to work a lot different in the open world template than you might expect. So normally, if we come up here to do our HLOD, you would enable the hierarchical LOD outliner, which actually isn't available. And that's because for HLOD, you just come up here and you build your HLODs. However, to set data in your HLOD, we have a little actor. I'm just going to go ahead and make a new one. And it is under miscellaneous, and it's called an HLOD layer. I'm just going to open it up. And the cool thing about these is that we can actually adjust or change. So we have instancing, which would just take whatever is there, swap it out with an instance. We then have merged mesh that would just take everything and merge it all down. We then have simplified mesh and approximate mesh. So simplified mesh will replace it with a brand new set of geometry and materials. And then approximate mesh does the exact same thing. This one's just for Nanite objects, or objects that have a lot of vertices inside of them. And the cool thing about this is that I can have one of these LOD layers for all types of different stuff. So I could have one for foliage, I could have one for roofs, I could have one for walls, I could have one for the river stones, I could have one for pretty much anything that I would want, and then I can control, let's see if I do like a simplified mesh here. You can see here I have my proxy settings, as well as my merge material. So I can control all the settings that I want for each one of those. So I no longer have to have the HLOD settings just applied across the entire map. I can now have HLOD build things specifically how I want them. So for example, you might have it set up where you use instancing specifically on all your foliage, but let's say that you have a building that is made out of a bunch of identical static mesh parts, where you could have that set down to mesh merge so that it's going to merge everything down. Let's say that you found out maybe mesh merge isn't doing good enough for you at objects in the distance and they need to be just drastically reduced. We can then have those objects in the distance. Instead of that, we could simplify their mesh. And then under here, under our proxy, we can change basically how complex that mesh is going to be generated. And then under our materials here, we can determine what materials we want to use for it. So do we need a roughness map, or can just a constant parameter work? Now to build this, and I've never built it on this computer, so I'm not going to try, but we just come up here and we build our HLODs. One of the cool things about this, though, is that it is multi-core process enabled. So the more cores you have, the faster this will build. It actually does a really, really, really good job of building your HLODs. Let me come here and do something really quick so we can see them. There's a little bit of a bug inside of Unreal that prevents this from happening. So we are just going to do this really quick. We're going to come all the way down here. And then what we're going to do is we're going to disable our landscape. Yeah, I know. All right, so this right here, this lovely little thing you see with the cross in the center is my HLOD. This cross, this will be fixed. This is actually a bug. The cross is signifying that for whatever reason, when this is built, it doesn't think that that stuff in the center needs to be rebuilt. It thinks that it's loaded all the time. That's why it's showing up like with this cross. But this here in the distance, these are my HLOD. So this is my HLOD of the terrain. And it's actually very, very fast to build. And the best part is once you set everything up with an HLOD layer asset, you can just build. And that's all you have to do. You just build. You don't have to worry about it. You just build it, and it will be done. So now the next two items, virtual textures and virtual shadows, these two things aren't necessarily required to make open worlds work, but they will help that content run a little faster and work a little better across multiple platforms. Virtual textures is needed to do the mini-map, but that's the only thing that you need it for, unless you are actually utilizing virtual textures through your project. And the virtual shadow maps are going to work really well. And I don't know if you can see this or not, but this image right here, what I did is I just blew up that little little section right there to kind of show you basically the advantages of the new shadowing system versus virtual shadows. And one of the things also on virtual shadows that we will get is if the roof tiles, notice how each tile kind of has a little bit of a shadow coming back because of the way of the light. We would never been able to see that information with our old school shadow system simply because we wouldn't have enough resolution. There just wouldn't be enough resolution to show that type of detailed shadow information in anything that would be even close to acceptable performance at runtime. And again, virtual shadows aren't necessarily needed to use the open world tools, but all of this stuff put together is going to help, right? It's like you don't necessarily need windows on your car for your car to work, but it does keep the bugs out of your face, right? And then the other one is going to be Nanite. So Nanite is just our virtualized geometry. This is literally going to make your project run insanely fast with an insane amount of detail. Let's see, Control H. And I'm just going to try to do this really fast. Go Shift, enable that. And then let's just hit 1. And like all these little rocks here, these are all Nanite meshes. And what I did is I actually just like duplicated this out by holding Alt. And then I would come here and I would scale it down just a little bit. Pull it up. And what this would do is it would give me these just big rocks, medium-sized rocks, and small rocks, all made from the same asset. And if we look at this asset, let's just hit Control E. This is 999,000 triangles, or basically all of the triangles that it took to build Virtual Fighter inside of one static mesh, which is pretty cool, in my opinion. So the last slide that I have here is going to be the debug commands. So there are 2 debug commands that we can run. There is the WP runtime.toggle runtime hash 2D grid. And basically all this is going to do is it's going to show you where your assets are loading, where you are inside of the world. So as I traverse through my level, it's going to show me what's pending loading, what is currently being loading, or more importantly, if something failed to load. I can see maybe something didn't get cooked right, or maybe something wasn't set up correctly inside of the grid. And this tool can help me do that. And it's not on here, but let me just pop over here to this. And we did this a little bit earlier in the talk, but I'm going to hit the tilde key or the backtick key, and I'm going to go to my 2D grid just so that we can see this again. You can see here the green indicates we have a little key down here at the bottom. Let's see if everybody can see that a little bit better. But basically, we show our unloaded, our loaded, unloaded still around, loading but not visible, marked visible, loading visible, preloading, failed to load, and then making invisible. So right from this, we can actually see, is something loading? In this particular scene, I don't have the gameplay or anything like that, but maybe there is something that is toggled far off in the distance that the player has to happen to trigger. And this little runtime 2D grash, it can show us like if something isn't going to load, or if something is pending loading, or if something isn't in the right grid cell. It makes it a lot easier to try to debug what is going on instead of just randomly clicking on stuff and trying to figure out, why isn't this loading? Does it need to go into another cell? Is it pending kill? What is going on with this? So it's just one of the many tools that you have inside of your tool belt to work with, because this is complicated. This is complicated stuff, and that's okay. We'll take the complication out of it by using the template and making sure that we use the debug tools that are provided just to have a look around at what's going on. So let me just pop back over here, and we'll go over our wrap-up. And so in today's training, we talked about the open world tools overview, just basically went over kind of what this tool set is, what it can do for you in your projects. We then talked about the open world template, why you should use the template. Well, it's already set up for you to be successful. So don't fight the template, use the template at all times. We then talked about each of the open world tools and kind of what they do. And then we finished up with the open world debug commands. So I have like a minute left. Probably not enough time to run up to the mic, so I will open up to questions. You can just come see me over at the side. And that is it. I appreciate everybody coming to my talk, and I'll see you next time.